Okay, so I was able to use my gauge block, this old one, in here, and the force of the micrometer thimble to actually push this in even further. But now it's flush with this, so I can't go any further with the block. But I want to continue to push this out in that direction, so I got myself a dowel pin, and the dowel pin should be small enough in diameter that it will fit into that hole as I continue to push that out. Now I'm only going to be able to push it so far before this piece right here becomes a problem. So I'm going to push it out just a little bit further, and then I'm going to see what I can do about getting this piece out. I see a hole in this piece right here, so I'm pretty sure that that hole is probably to put a tool in to unscrew this piece from that piece, because I think you have to unscrew this piece so that you can push this all the way out. Yeah, that's working. Another piece of swarf. Oh, look at that. Now that's starting to move more freely. Let's see what I could find for a tool to fit in that hole. Let's see if these tiny Allen wrenches I have, see if one of these is small enough to fit in there. It's still strong enough to turn this thing. Oh, I wonder if I can just grab this thing with these pliers. Nope. Didn't want to do that, but it just wasn't going to come out. And I know I could probably find a drill bit small enough to fit that hole, but I bet you as soon as I put the axial load on the drill bit to try and unscrew this, it would snap off, because drill bits are brittle. I could have also just tried to clean this as best as I could and lubricate it without taking this out. But this is really still tight and stiff in there because there's garbage in there. So this is going to be the way to do this so that it really gets a good cleaning. There we go. It's out. Okay, wasn't easy, took a little bit of work, but I was able to get this all cleaned up. So now I can insert this in here. It's a very, very tight fit. It's precision, but it moves back and forth freely. There's a little bit of a scratchiness in there because it's dry. So I'm going to put a little bit of oil on there. I took the thimble out. I cleaned the bore, cleaned out all of the old sticky oil that was in there. And then when I had it nice and clean, I put a really light machine oil on the threads and on the nut that's underneath here, the like retaining nut, because I noticed that the inside of this kind of scrapes on that and was making an unpleasant sound. Now this is Nice and smooth, easy to turn, quiet, the lock works properly, everything's working well. Okay. Let's see. All right. That looks good. Now I gotta get this pin in. So if I put my finger on the back here now and push lightly, simulating the spring that would be in there, I can see how this is supposed to open this up. Okay, good. Now, next kettle of fish, I believe, is going to be this. So there's a little tiny ball on the end here that's going to ride on that face up inside here. So that's pretty self-explanatory. So we'll just push this back out of the way. There's a pin sticking out on the bottom here that has to go in this hole. Goes in that hole like so. Then this little block has two little pins that locate it in two little holes right there, and then of course the screw holds it in. But then there's also a hole underneath this little metal tab that this top of this pin that this arm pivots on rides in. Now, I don't want to tighten that screw down until I'm sure that that is in the proper place. Oh, you know what I got wrong here? Look at this. I got this arm. This part of the arm needs to be between these two pieces. I forgot about that. Yeah. Getting that into position is a little tricky. There we go. See it? Just moved. If I move this back, this just pivots. That much. Tiny, tiny bit. Now, the part I'm really dreading. Figuring out how the heck this gets dealt with. Alright, so this block goes in like this. I think this is supposed to be wound around once. Call me crazy. I don't know, given the way I just did this, I don't see any way in hell how that needle's going to be lined up correctly. See what it's doing there? It's kind of in the center position, and if I push it in, it deflects to the left, which is what it should do. But when I let it go, it goes back to center, and I think it should go to the right. Or wait a minute, maybe when this comes back? No. Yeah, I don't think that's right. Alright, well I think I could put this washer, which goes underneath this hole, acts as a spacer between the back plate here and the Alright, so I think I need to have this back cap on with the spring in there putting tension on this before I put this other piece in, which means I have no choice other than to try and find that spring that went flying. Well, I can't believe my luck, but I actually did find that spring. It actually, I think it ricocheted off the side of my arbor press and landed on the rollaway toolbox behind my bench. So, anyways. Well, I'll tell you what, I wonder if that's even the right spring. I'm beginning to think it's not. I'm thinking the spring that went in here, even though this will fit in here, like that, I'm thinking, well, maybe it is. No, it can't be the right spring. It's putting way too much tension on that thing. There's no way this little arm could fight this spring. This is just a spring I found on the top over there and figured it was the right one, but it's not. Ah, I found it. Laying here on the bench the whole time. Just kind of rolled underneath something. So anyways, this sure looks like the right spring, because it can go down inside this part. And I can, so far, I can overcome the resistance of that spring with the lever here so that it works correctly. Now, unfortunately, I lost a tiny pin that fell out of this wrench. I'm thinking this needle has to be to the left. Wonder if these spots are going to come off of this. Alright, so now that this thing's actually starting to show signs of possible resurrection, I got to think about how the hell you calibrate this thing. So my thinking is that you put in a standard and you set this for 1 inch, and then you want the needle to be at 0, and that you adjust this to make that happen. This is all theoretical, mind you. So I've got a 1 inch standard, and then I guess I could check it with some gauge blocks. So the good news is that as I tighten it down, you can actually see the needles moving. So that's actually 2/10 over. So that's actually now right on 0, and the needle's too far to the right. I'm going to have to put this face on, okay? But I got to get this needle to come back to near the center. So the first thing I'm going to do, just out of curiosity, is see whether or not, lock this thimble a little bit. All right. See whether or not when I turn this, does it actually have an effect on the needle there? Because if it doesn't, then I know I'm really barking up the wrong tree. See, unfortunately, that's not doing anything. All right, so this is tricky. So what I figured I'd do is ignore the standard for now, and I close the micrometer all the way down to 0. So the jaw's closed. At this point, when this is at 0, this is actually pushing pressure, pushing this anvil against the spring that's inside here and moving the anvil in a little bit. This arm right here is just kind of free floating, okay, because it's got that little finger that's pushing on the back side of that void in the anvil, so that if I move the thimble out this way and the anvil moves in this direction, it will push on that point on the top here, which will end up moving this rack to the left. Alright, so if I do it like this, so that gravity is allowing this rack to fall down this way, and I back this out, you can actually see it move. Alright, so what that tells me, I believe, what that means is that I need to have the rack all the way over to the right when I install this block with the gear and the pointer. The other problem I'm having is when I go to put this part in, this just wants to move. So I can't guarantee that I'm getting right where I want to get. So I need this to be all the way over here up against this stop, I believe. Then if I keep this all the way up against the stop and I position this little pointer assembly so that it's pointing at 0, I'm thinking that's gonna actually make this work. Now, the other problem I've been having is these needle nose pliers are not really cutting it. So I went and found my, I believe these are called a hemostat. I'm not positive on that, but these are generally used in the medical profession. But we're going to use them for down in here. And actually, I think I can even do better than that. I think, let me get some tweezers. I thought I had a pair of tweezers that actually had a locking ability to it where I could actually close them down and keep them closed. Because what I'd like to do is I'd like to maybe see if I can't keep this. Oops. Well, actually, I can use the spring effect of the tweezers. In other words, if I insert these in here, yeah, it's not really staying though. The reason why I'm trying to do it up here is because over here I need clearance for the needle and everything. So well, that might work. Also not entirely positive how much to preload this needle. I'm sure at least once around. Maybe it should be twice around. Yeah, let's go with 2 times around. Aha. This pin was out of position. It's part of my problem. I can't get it into the 0 position. It's driving me crazy. I seem to be close right here, so just for the heck of it, let's tighten this down. So I appear to be 6/10,000ths off. See, that seems screwy. Doesn't matter how much I push this in, I can't get that to come back to 0. So how would that ever get to the plus side? How would that ever be over? Like that's at 0 right there, and when I go to that, I should be pushing the needle towards the plus side, I would think. Could be something as stupid as like 1 tooth off, huh? Well, guys, I've been messing with this thing, and I just can't seem to get it exactly right. I appear to be 10 thousandths off, if I'm reading this correctly. So I've got the 1-inch standard in there, and I'm looking over here, and right now I'm at about 3/1000ths over. Is 2/1000ths over. See the needle's coming up? 1/1000th. Right there, it's on 0, so that should be 1 inch. But you see, it's saying that I'm about 11.5 10,000ths over. That's 0.0001. If I close this all the way down, is 10 thou, 5 thou. And you see right there I'm touching. So when I bring this over, see how it's showing 0 here, but I'm exactly 1 division off over here. So I'm 1/1000th off here. And when I go that extra division, look what happens here. This is almost just over 10 10,000ths plus. So I think right now, if this was working correctly, that should be on 0. And then from what I could read online about calibrating these things or checking the accuracy of these things, what you're supposed to do is you're supposed to check it here at closed up at 0, and then check it at several locations with different gauge blocks to see if it's consistently the same amount. Just look at this under the magnifying glass to make sure I'm reading that correctly. That's like spot on the 11. So that's 11 10,000ths. That's 200,000ths right there. I'll lock it at 200,000ths. I should be able to slide this 200,000ths gauge block in when I press this button, and when I release it, it's right on 0, still on 11. So it's good that it's consistent. Let's go to 300,000ths. So it's just starting to tighten on that now. I'm at 3/1000ths over. 2, 1. Zero. Again. All right, so now it's at 11.5, so now it's creeping up a little bit. Yeah, that's now at 11.5. I don't know if that's coming out. If you can see that or not. Still at 11.5 thousandths, maybe a tiny bit strong of 11.5. But we're still talking about tenths of a thousandth, right? So that's, that's crazy small. I would say that, if we could send this out and have it calibrated, probably would be fine. I think it's, we could almost call this a successful repair, except for the fact that, well, like I just explained, that, I think it's supposed to read 0 there. So the next question is, what the heck is the purpose of this adjustment? Because all this adjustment does, that I can see, is as I turn this in, it's just going to put more tension on that spring. But that doesn't do diddly to correct our problem over here. I could turn this, with the wrench, while I've got that block in there, and that needle won't move at all. So go figure. I'm going to clean up this crap that's on this plate. Just about there. So I figured out that the purpose of this right here, it's not a knob at all. It's just a cap that you can unscrew to get to this locking nut. If you loosen this locking nut, you can move these two little tabs to preset these two red lines, these two red pointers, to whatever your tolerance is that you're. Remember, this is a comparing micrometer. It's made to compare during inspection work. It's not really made to take a direct measurement off of like something you were turning in a lathe. This would be used for quality control. So you get a little bit of a tolerance that's allowable. You could set that here. So that's all that is. And then of course there's a locking nut here, so that once you preset this to whatever you're supposed to preset it to, which I believe there's actually a special device that's used to measure the force of the anvil here. How much spring tension, I don't know, but I think you need something special to do that. So this is not your typical micrometer here. So Mitutoyo makes a version micrometer like this. It's actually got a dial indicator built right into it here. Works on the same principle though, and they're really expensive. Again, we'll just try it one more last time before we put it in its little box for a nap. It's like halfway between 11.5 and 12. Never did figure out what this was for. I think we can safely throw that out though. You know what, I'm going to do one more thing because it's bothering the heck out of me. And that's going to be, I'm going to clean the inside of this because the excess oil keeps ending up on the reading area here and it's driving me crazy. That's interesting. Now, fully closed at the 0, it's at the same location. It's just below the 12. And the other thing I just noticed was that's like the max deflection. So if I go further, it doesn't go any further. So that is going to... This micrometer would definitely require the magic touch of someone with more skill than myself. I'll have to ask Mark over at MR Tool whether or not he's ever done anything with one of these. Alright, but that's going to be a wrap. Hope you guys found this interesting. You know, if nothing else, you got to see what the inside of one of these things looks like, and its its basic principle of operation. Alright, if you like what you see, please hit the subscribe button and the like buttons. Take care. Good night.